my third question, how high does the ball go? And how long does it take to get there? How high, what is that maximum height? And what's the particular value for t that matches that height? How long does it take to get to that maximum height? We actually answer these questions in the reverse order. I'm going to find t first and then use that to find maximum height. Because think about what you've learned in class. And if you haven't learned about this stuff, you'll learn very soon. The values where the graph crosses the x-axis, those are the x-intercepts. There's one over here, and as we saw in the previous video, if we let the graph go all the way back to there, there's also one over there. We don't really care about that one. That doesn't really make sense in this context. Those are the x-intercepts. That's one of the key features of a parabola. Another key feature is this point up here, this maximum point. We call that the vertex. The vertex of the graph is that turning point, the place where it's either a maximum or a minimum, depending on if it's an arc shape. If it's an arc shape like this, or a U shape like this, maximum here because the maximum is at the top, minimum because the turning point, the vertex, is there at the bottom. You think of maximum as a top of a parabola, minimum as a bottom. Then we have the axis of symmetry, which is this vertical line that passes through the parabola that cuts it right in half. It's an exact mirror image on one side of that line versus the other. That's the axis of symmetry. And it's that I want to find first, because that crosses the x-axis at the place where the maximum is. And since, in this case, the x-axis represents time, and the y-axis represents height, finding that place will tell me what time. Will tell me the time it takes for the golf ball to get to that height. The height, then, will be determined by the vertex. The y-coordinate, the xy coordinate of that point. The x-coordinate will be the time that it reaches the maximum height. The y will be that maximum height. So I need to answer that question first. I need to find the axis of symmetry. There's two ways to find the axis of symmetry. One tends to be more convenient than the other. It probably won't come as any surprise that the axis of symmetry, actually you should probably figure this out anyway on your own. The axis of symmetry relative to those two x-intercepts is right in the middle of them. So strategy one for finding the axis of symmetry, finding axis of symmetry, average the zeros. Take the zeros, add them up, divide by 2. If you remember from the previous video, our zeros are negative 2.5 and positive 9.5. There's 2 of them, so I'm going to add them up and divide by 2. Negative 2.5 plus 9.5 divided by 2. Negative 2.5 plus 9.5 is 7 divided by 2, 3.5. So that's actually the answer to my question, or the second part of the question. After 3.5 seconds, it takes the ball 3.5 seconds, 3.5 seconds to get to that maximum height. Sometimes, though, this is not a terribly convenient thing to find. Sometimes the zeros are really tricky to find. Sometimes you can't find them at all. Sometimes they don't even exist. Sometimes you have a parabola that doesn't even have any zeros, like a graph that looks like that. Clearly, there's still a vertex to that graph. There's still an axis of symmetry. So we need another way to find the axis of symmetry in those cases. The other way is to use a little formula. The general form, in this case I'm going to use t instead of x, negative b over 2a. Now, we have to be careful exactly how this works, because this refers to the general form for a quadratic equation. This whole ax squared plus bx plus c that your teacher might have used. In this case, a is, in our case of projectile motion, we actually use 1/2 a instead of a itself. This is not the same a as what we're using in the projectile motion area, but it's the leading coefficient. So twice the leading coefficient, stick that underneath the middle coefficient. That's all it really comes down to. So in this particular case, I could do negative 112 divided by 2 times that. So 2 times negative 16. That gives me negative 112 over negative 32. Take a 16 out of both of those. I have 7/2, which is 3.5. So regardless of how you get to there, using either the formula x equals negative b over 2a, or just by averaging the x-intercepts, or the zeros, you can find the x-symmetry. That gives us that time. That's the answer to the second question. The second question, how long it takes to get to the maximum height? 3.5 seconds. Now, we know how long it takes to get to that height. We know how long it takes to get to the maximum height. I'd like to know what that maximum height is. And gosh, if only we had an equation that told us the height of the ball after a certain number of seconds. If only we had an equation that told us the height as a function of the time. If only we had that. We're just going to take that number, plug it in here. I'm going to do h of 3.5. I'm going to plug in 3.5. 3.5 squared plus 112 times 3.5 plus 380. Punch that into your calculator. This isn't something you need to do by hand. And you'll get that the actual height is 576 feet. The maximum height is 576 feet, and it took 3.5 seconds for the ball to get to there. You could do this all on your calculator. You can find the maximum. Talk to your teacher in class about how to do that. You can find the maximum. If you have this equation plugged into your calculator, typed into your calculator, you can actually have the calculator tell you both this and this. You can have the calculator find that point up there. But talk to your teacher about that.